Today we're going to talk about factoring the difference of two squares. This is kind of a nice little shortcut method. If you have two squares that are being subtracted, a squared minus b squared, you can factor that as a plus b times a minus b. And if you're unsure of why that works, just check this. A plus b times a minus b. Go ahead and FOIL that. A times a is a squared. A times negative b is negative ab. B times a is positive ab. And b times negative b is negative b squared. The middle terms cancel, and you're just left with a squared minus b squared. Okay, so let's do this problem here. Determine whether the binomial is a difference of two squares. If so, factor. If not, explain why. So what we're going to do, let's set up parentheses. We'll see if this works, first of all. What do you have to square to get 1? Well, that would be 1. In other words, what's the square root of 1? So we'll put that in for our first factor. What do you have to square to get 4x squared? Well, that would be 2x. And all you do is put in a plus and a minus. And that's it. Now this only works if you can actually take the square root of your term. So let's keep going and see if this will work on all of these. I bet it will on some, but won't on others. Now, what do you have to square to get p to the 8th? Well, it's actually p to the 4th. So let's put in p to the 4th. We'll see if that works. What do you have to square to get 49? That would be 7. What do you have to square to get q to the 6th? That would be q to the 3rd. So it looked like that these were squares, so now we'll just put in a plus and a minus. So here we had 7q to the 3rd. So we have p to the 4th plus 7q to the 3rd times p to the 4th minus 7q to the 3rd. Now let's do this next one. Let's see if this works. What do you have to square to get 16x squared? That would be 4x, so we could write that down. What do you have to square to get 4? Well, that would be 2. Now, can you square something to get y to the 5th? And no, you can't. This exponent would actually have to be divisible by 2. So this one is not a difference of two squares. Okay, so we cannot factor it by this method. Now let's try this next one. Let's set up our parentheses. What do you have to square to get 3p to the 2nd? And you might be saying, wait a minute, I can't square anything to get 3. I can't take the square root of 3 and get a whole number. So this is another one, which is not a difference of two squares. Both terms have to be squares, and they both have to be separated by a minus sign as well. Okay, so now let's try this next one. Set up our parentheses. What do you have to square to get 100x squared? That would be 100x. I'm sorry, not 100x, 10x. Thank you. Sorry about that. 10x. What do you have to square to get 4y squared? Well, that would be 2y. And put in your plus and your minus. And really, it doesn't matter whether the addition sign comes first or the minus sign. It really doesn't matter. Now let's move on to the next one. We have x to the 4th minus 25y to the 6th. What do you have to square to get x to the 4th? That's x squared. What do you have to square to get 25y to the 6th? Well, that would be 5y to the 3rd. You're basically taking the square root. So let's plug in the x squared, the 5y to the 3rd, and then just fill in your plus and your minus. Okay, so this is just a neat little shortcut for factoring problems or factoring polynomials that are the difference of two squares. This only works in this particular case. You have to have two squares separated by a minus sign. So I hope this helps. Thank you very much.